Welcome! In this tutorial, we're going to learn about one of Python's most practical features, context managers. If you've ever opened a file, connected to a database, or acquired a lock, you've already run into a situation where context managers can make your life much easier. By the end of this video, you'll understand what they are, why they matter, and how to build your own from scratch. Let's get started. Let's start with the problem context managers solve. Imagine you're writing data to a file. You open it, write some content, and close it. Looks fine, right? But what if an error occurs between opening and closing the file? The close line never runs, and you're left with an open file handle. This can cause data corruption or resource leaks. The traditional fix is a try finally block, which works, but is verbose and repetitive. Context managers give us a much cleaner, safer alternative. So, what exactly is a context manager? It's an object that defines what should happen when you enter and exit a block of code. Python's with statement is how you use one. Look at this file example rewritten with a context manager. The file is automatically closed when the quotes with block ends. No try finally needed. Even if an exception is raised inside the block, Python guarantees cleanup. Think of it like an automatic door that always closes behind you, no matter what. Let's see how it works under the hood. Every context manager relies on two special methods. The first is $enter, which runs at the start of the with block. The second is $exit, which runs at the end with or without an error. Let's build a minimal example called greeter. Watch as the code executes step by step. First, $enter runs and prints starting session. Then, our code inside the with block runs. Finally, $exit runs automatically. You don't call it yourself. Python handles that for you. Now, let's build something practical. A code timer context manager. This measures how long a block of code takes to run. In $enter, we capture the start time using time.perfCounter. Then inside the with block, we run our computation. When the block ends, $exit calculates the elapsed time and prints it. This is a clean, reusable timing utility. No setup or teardown code cluttering your logic. You can use this pattern for logging, database transactions, or any resource that needs setup and cleanup. Writing a full class is sometimes overkill. Python's built-in Contextlib module lets you create a context manager using a simple generator function with the @contextManager decorator. Here's how it works. The key concept is the yield keyword. Everything before yield acts as setup, like $enter. Everything after yield acts as cleanup, like $exit. The finally block ensures cleanup always runs, even if an error occurs. So when should you use which approach? Use a class when your context manager needs to hold state or be reused in complex ways. Use @contextManager for simpler one-off cases. You can use more than one context manager on a single with line separated by a comma. Watch how both files are opened on entry and both are safely closed when the block ends, regardless of what happens inside. This is much cleaner than nesting two with blocks. Notice that the resources are closed in reverse order. The writer closes first, then the reader. This last in first out pattern is the same as a stack, and it's guaranteed by Python. By default, exceptions raised inside a really with block propagate normally, but you can intercept and handle them inside $exit. If $exit returns true, the exception is suppressed. If it returns false or none, the exception continues to propagate. Look at this safe runner example. It catches value error specifically and suppresses it, so the script continues after the with block. A word of caution: only suppress exceptions intentionally. Silently swallowing errors can make bugs very hard to track down. For common cases like ignoring a file not found error, Contextlib provides a cleaner shortcut called suppress. Instead of writing a try except block, you simply wrap the risky code in a vary with suppress statement. The specified exception is caught and silently ignored. This is more readable than a bare try except when you simply don't care about a specific error. It's a small tool, but it makes your code noticeably cleaner. A context manager is an ideal pattern for managing database connections. Here's a simplified example. In dunder enter, we establish the connection and return it. Inside the with block, we use the connection to run queries. In dunder exit, we always close the connection cleanly. Even if a query fails mid-execution, the connection is guaranteed to be closed. This pattern prevents connection leaks, which are one of the most common causes of database performance issues in production applications. You can nest with blocks when you need finer control over the order of entry and exit. Watch what happens here. First, the outer step enters load config. Then the inner step enters initialize database. Your application logic runs. Then the inner step finishes first. And finally, the outer step finishes. Context managers always exit in the reverse order they were entered. This is called LIFO, last in, first out. It's the same pattern as function call stacks, and it ensures resources are released in the correct order. Python ships with several useful context managers beyond open. For file handling, you have open, which is probably the most commonly used. For threading, threading.lock gives you thread-safe locking. For decimal arithmetic, decimal.localContext lets you temporarily change precision settings. For exception handling, Contextlib.suppress silences specific exceptions. And for testing, unfent.mock.patch lets you mock objects during tests. These are all built in, well-tested, and ready to use. Here are the key best practices to remember. First, always pair dunder enter with dunder exit in class-based context managers. Second, use it context manager from Contextlib for simple one-off use cases. It's less code and just as effective. Third, don't suppress exceptions blindly. Only return true from dunder exit when you have a deliberate reason. Fourth, combine context managers on one line when managing multiple resources together. It keeps your code flat and readable. And finally, favor context managers over manual try, whenever you're dealing with resources that need cleanup. Context managers are one of Python's most practical features. The with statement automatically handles resource setup and teardown. Every context manager implements dunder enter and dunder exit. You can build class-based managers for complex logic, or use it context manager for simpler cases. Once you start using context managers regularly, you'll find your code become significantly cleaner, safer, and easier to maintain. Thanks for watching, and happy coding!